power loss. So in our syllabus, basically power loss we'll study in two circuit. First one is R circuit, and the second one is RLC circuit. Power loss in RLC circuit. RLC circuit. So in case of R circuit, the formula that we have to derive is P is equal to VRMS IRMS. Power loss is equal to VRMS into IRMS. In case of RLC circuit, power loss is basically VRMS IRMS cos phi. VRMS IRMS cos phi. Now basically what is cos phi? Cos phi is called as power factor. Cos phi इसको बेटा हम बोलते हैं पावर फैक्टर. पावर फैक्टर. और ये होता क्या है? ये रेशियो है R बाय Z का, रेजिस्टेंस पर इम्पिडेंस. रेजिस्टेंस और इम्पिडेंस का ये रेशियो है, राइट? चलो अब इसको डिराइव करते हैं पावर सर्किट का डेरिवेशन. इन केस ऑफ आर सर्किट, बहुत ध्यान से सुनना है, ये सिंपल. नाउ स्टेप्स दैट वी हैव टू फॉलो. कुछ स्टेप्स बता रहा हूं, ये अपने को फॉलो करना है. सबसे पहले we will try to write the voltage expression. V is equal to V naught sine of omega t. Step number 1, try to write voltage expression. Next, step number 2, current formula. Try to write current. Third one, step number 3, try to find instantaneous power. Instantaneous power, which is nothing but product of V into I. Instantaneous voltage into instantaneous current. Fourth step, we need to find average power. So learn this basic formula. Average power is from 0 to t, P dt, P instantaneous dt upon capital T. That means what we are doing, we are calculating average power for one complete circle, one AC cycle that consists of positive half cycle and negative half cycle. This is called as one cycle. So we are calculating average power loss in one cycle. That is from integration from 0 to t. So we have 0, this is t, this is basically t by 2. So from 0 to t, P dt by capital T. Okay, over capital T, that is one time period. Now, step number 1. For the derivation purpose, step number 1. As I have told you, first step, we need to write the voltage expression. Step number 1, voltage expression. So in case of R circuit, the voltage expression is V is equal to V naught sine of omega t. V is equal to V naught sine of omega t. Similarly, I, current, step number 2, current. So I is nothing but I naught sine of omega t. I is equal to I naught sine of omega t. Step number 3, we need to find instantaneous power. Step number 3, instantaneous power, which is nothing but multiplication of voltage into current, V into I. So V into I. Now just substitute the values here. So V naught sine of omega t into current, and what is the value for current? I naught sine of omega t. I naught sine of omega t. Now this V naught I naught, and we have to multiply sine omega t with sine omega t, which is nothing but sine square omega t. Sine square omega t. So this is the value for instantaneous power. So instantaneous power is nothing but V naught I naught sine square omega t. Now we have to calculate average power, that is nothing but power loss during entire cycle, one cycle. So average power from 0 to t, P dt upon capital T. We need to find average power loss. So basically what we have to do, we need to integrate this part. We need to integrate this instantaneous voltage. Instantaneous power will get the average power. So basic rule for integration, We'll follow basic rule for integration, right? So integration of from 0 to t. So this is instantaneous power. So V naught I naught sine square omega t into dt upon capital T, upon capital T. Now it is very important to note, in case of integration, what we have to do, we need to integrate the term that has t with it. So that means we need to integrate this sine square omega t. Else every part is constant. So we need to bring the constant outside this integration sign. So we have V naught I naught by t, integration from 0 to t sine square omega t dt, sine square omega t dt. It is very important to note, this is a property of definite integration. The property says that, property of definite integration. So this property says that ki integration from 0 to t sine square omega t dt is basically t by 2. From 0 to t sine square omega t dt is basically t by 2. Or integration from 0 to t cos square omega t dt is also basically t by 2, is also t by 2. So we'll use this identity here, or this result here. So average power loss is nothing but V naught I naught by t, and the integration from 0 to t sine square omega t dt is nothing but t by 2. Just put the value t by 2 here. Now this t gets cancelled out. You can write 2 as root 2 root 2. So why we are converting root 2, why we are writing 2 as root 2 root 2? Because V naught by root 2 is VRMS. Similarly, I naught by root 2 is IRMS. So V naught by root 2 is VRMS into IRMS. So we can write the answer in terms of VRMS into IRMS. So VRMS into IRMS. So this is basically power loss in case of R circuit. Power loss in case of R circuit, right? So I will repeat the steps once again. First, what we have to do, beta, we need to write voltage expression, V naught sine of omega t. Second step related with current, you need to write the current formula, I is equal to I naught sine of omega t. Then instantaneous power, multiply V with I. So V naught I naught sine square omega t. This is the third step. Fourth step, we need to find average power. And what is the average power? That is from 0 to t, P dt by capital D. That means you need to integrate for one complete cycle. Now in integration, what we have to do, we need to take V naught I naught by t as constant outside, and there is a need to integrate sine square omega t dt from 0 to t. Now the property of definite integration says that is integration of sine square omega t dt is t by 2, or integration from 0 to t cos square omega t is t by 2. So we just substitute this value here. Okay, instead of sine square omega t, what we are doing, we are writing t by 2. So this t gets cancelled out. So we are left with V naught I naught by 2. Now 2 can be written as root 2 root 2. So V naught by root 2 into I naught by root 2. So V naught by root 2 is VRMS, I naught by root 2 is IRMS. So this is the required answer. Power loss for R circuit is nothing but VRMS into IRMS. I hope the concept is clear. Any doubt in this step?
नहीं.
Okay. Now next article, power loss in RLC circuit.
आप 2 मिनट दिखा सकते हो क्या?
Power loss in RLC circuit, beta. Power loss in RLC circuit, right? Done? Okay. Now next article is RLC circuit, beta. RLC circuit. power loss. Power loss. Step number 1, draw RLC circuit. Resistance, inductor, and capacitor all connected in series with an AC source. Yes. So we have R, L, and C, right? So voltage across resistance is VR. Voltage across inductor is VL. Voltage across capacitor is VC. Across capacitor is VC. Now, step number 1, we need to write voltage expression. So what is voltage expression? V is equal to V naught sine of omega t. V is equal to V naught sine of omega t. Similarly, write the expression for current. So I is equal to I naught sine of omega t plus minus phi. Plus minus phi means positive. We generally denote by for capacitor, because capacitor, in case of capacitor, current leads the voltage by an angle of 90 degree. In case of inductor, current leads voltage, lags voltage by an angle of 90 degree. So plus shows that capacitor and negative shows for inductor, and phi is what? Phase angle. Phi is what? Phase difference or phase angle. Now step number 1, step number 2. After this, we need to find instantaneous power. Step number 3, we need to calculate instantaneous power. So what is basically instantaneous power? That is nothing but V into I. V into I, voltage into current. So V into I. So we can write the formula as V naught I naught sine omega t into sine of omega t plus minus phi. Sine of omega t plus minus phi. Now next, what we can do, beta, we need to solve this expression. V naught I naught sine omega t into sine omega t plus minus phi. Now, how to solve such type of expression? We need to apply sine A plus B formula here. Sine A plus B formula. So what is sine A plus B? That is sine A cos B plus minus cos A sine B. Cos A sine B. I repeat, V naught I naught sine omega t into sine omega t plus minus phi. So we have to solve this term first. Sine A plus B, apply the formula sine A cos B plus cos A sine B. Now open the bracket. So we can write it as V naught I naught sine omega t. Apply the bracket, sine omega t plus phi, plus minus phi. What is the formula? Sine A cos B. So sine omega t cos phi plus minus cos omega t into sine phi. Sine phi. Remove the bracket. So once you remove the bracket, you need to multiply these terms inside the bracket, right? So V naught I naught, what we are doing, beta Felicia, we are just multiplying this part, right? So sine omega t into sine omega t is nothing but sine square omega t cos phi plus minus. Now multiply this term with cos term. So we have V naught I naught sine omega t cos omega t sine phi. Cos omega t sine phi. I hope the concept is clear.
Yeah.
First step, V naught, write the expression for voltage, expression for current. Third step, just multiply these two steps so that you can get instantaneous voltage. So instantaneous voltage is V naught I naught sine square omega t cos phi plus minus V naught I naught sine omega t cos omega t sine phi. Now next step deals with average power. Average power. So average power, we need to integrate this entire stuff. So for finding the average power, this is the final stage, step number 4. Step number 4. We need to find average power. From 0 to t, P dt by capital T, P dt by capital T, right? Now we have to apply this formula for individual terms. So first, we have to apply this for this term. So 0 to t, V naught I naught sine square omega t cos phi by t plus minus. After that, what we can do? we have to apply this formula for this term. This term. So the formula is integration from 0 to t v naught I naught sine omega t cos omega t sine phi by t. We have to individually integrate these two terms. So step number one in this particular integration, what we have to do, we need to take v naught I naught by t and cos phi as constant. So just take these two terms outside the bracket, outside the integration sign, right? So what we can do, we can write v naught I naught by t cos phi as constant. Integrate from 0 to t sine square omega t dt plus minus v naught I naught by t sine phi integration sign from 0 to t sine omega t cos omega t sine omega t cos omega t dt. Okay, now apply the property of definite integration as we already discussed. From
Sir,
0 to t sine square omega t dt, this is basically t by 2. From 0 to 2 sine omega t cos omega t dt is 0. So once you multiply 0 with any term, this term will be 0. Now we are left with v naught I naught by t. You can write this term like this: v naught I naught by t cos phi into t by 2 into t by 2. So this t gets cancelled out. T gets cancelled out. So we can write that term like this: v naught by root 2 into I naught by root 2 into cos phi into cos phi. So v naught by root 2 is basically VRMS. V naught by root 2 is VRMS. So VRMS into IRMS into cos phi. So this is the power loss expression in case of RLC circuit. VRMS, IRMS, cos phi. I hope the concept is clear.